So we're going to have to look for two factors of it that will equal minus 58, negative 58. Okay, since this is a big number, I'm going to have to do prime factorization. Okay, so what is 585 divisible with? So as you can see, it ends with a 5. So that 5 must be a factor of that. So it's going to be 5 here. So 585 divided by 5. Here is 117. 117 looks like I can get a 3 out of it. I'm just guessing. Yes, I'm right. So it's going to be 3 and 39. And the 39 looks like I can factor out a 3 out of it as well. So this becomes 13. 3 times 13. Okay, so 13, that's already a prime number, so that's it. Okay. So what are the factors of 585? So we have 1 and 585, of course. Next prime factor is 3 multiplied by 585 divided by 3, that's 195. And 585 divided by 5, that's 117. So 585 divided by the next factor, what's the next factor? Is it 13? Yeah, suppose so, it's 13. So 585 divided by 13, we get 45. So as you can see, 13 plus 45 is equal to 58. So that's a good pair right there. So we just need to figure out the signs. So I'm going to erase the plus there. We need negative 58, remember? Right here. We need negative 58. The negative 58. How do we get negative 58? What are the signs? Minus and minus. So minus 13 minus 45 is negative 58. Okay, there we go. So I'm going to erase this now. So here, I'm just going to write here 9x squared. And the minus 58x, we split that up into minus 45x and minus 13x. And then we just copy the 65. There we go. Okay. So here, we group the terms into groups of 2. So I'm going to have to group this, and I'm going to have to group this. Okay? And then we factor out their greatest common factor. So here, the greatest common factor is 9x. So it's 9x multiplied to x minus 5. And there we go. And here, it's going to be 13 multiplied to x minus 5. And then, don't forget the 0 on the other side. And now, we factor it out further. So, we get 9x minus 13 as one of the factors, and x minus 5 as the other one. And there we go. Okay, so one value of x looks like it's going to be 13 over 9. And the other one is 5. And there we go. And the next step, we're going to have to check if the roots are correct. And you will see now that one of the roots is bad. Okay, so now we're going to have to see if our roots are correct. And we just plug either one of these roots to x to see if it's going to be equal to 4. Alright? So here, we have 3 root of, let's test out 5 first. 5 minus 1. And here we have 4 over root of 5 minus 1. Okay, so this becomes 3 multiplied by root 4 and 4 divided by root 4. And this, we have 3 multiplied by root 4, that's 2. 3 times 2 is 6. And here we have 4 divided by root 4. 4 divided by 2, that's 2. So this is equal to 4. So as you can see, replacing x with 5 will make the equation equal to 4, so the root 5 is good. So this is good. So I'm going to put a circle here. And now, let us test if this root 13 over 9 is good. So let's see what happens now. So we have 3 root of 13 over 9 minus 1 minus 4 root of 13 minus 9 minus 1. Let's see what happens here. So this one right here is going to become 9 over 9. And this one right here is going to become 9 over 9 as well. So here, we're going to have 3 multiplied by the root of 13 minus 9 is, that's 4. And we have 9 here at the denominator. And right here, we have 4 numerator. And here we have, same thing, 4 over 9. And here, we just bring out the 2. This is going to become 3 multiplied by 2. And then we have another 3 at the denominator. And right here, we're going to have 4. And then there's going to be a smaller fraction here. There's going to be 2. And then we have a 3. Then I'm going to write here on the rightmost side of the workspace. So the 3 and 3 is going to cancel out. So I'm going to write here 2 minus. Here, 4 and 3 will just multiply together, making the numerator. This is going to become 12. And then 2 at the bottom. So here we're going to have 2 minus 6 is equal to negative 4. So as you can see, negative 4 is not equal to 4. It's not equal to 4. So this root, 13 over 9, is an invalid root. So you see, sometimes when you square the whole equation, it will sometimes result into an invalid root. And this example is a very good example of that. And that is why you should get into the habit of checking your roots. Alright, so see you in the next video.